Hey, this is Vedat from Programmership. In this chapter, we are going to talk about class and structure in Swift. Actually, class and structure are similar, but there are some important differences. We will also talk about that. Apple describes class and structure as class and structures are general purpose flexible constructs that become the building blocks of your program's code. You define properties and methods to add functionality to your classes and structures by using the already familiar syntax of constants, variables, and functions. Class or structure allows us reusability. We can create it once and use it in our code multiple times. Let's take a look at the similarity of both. Let me write down. Similarity, the properties similar, and the methods, and initializer. The other one is subscripts and extensions. Properties used for storing information in the class or structure. Method provides functionality for our class or structure. It just works like a function. Initializer used for initializing our class or structure. We are accessing the value of a class or a structure by using subscript syntax. An extension used for extending class or structure. We are gonna learn all of them, but let's write down the difference between class and structure. So these are the similarity, and let's write down the difference. Type is different between class and structure. Structure is a value type while class is reference type. I will explain what I mean in a few seconds. Let's write down the other difference. Inheritance, and the other one is initializer. Structure cannot inherit from other types while class can. Inheritance is a very important topic, so I think it is better to explain it in another chapter. Structure cannot have custom deinitializer while a class can. Well, let's begin with type. As I mentioned, structure is value type and class is reference type. What are these? What is the difference? When we create a structure and pass its instance to a new object, it will create a copy of that structure. So at the end of the day, we will have two different structures. If you change something within one of them, it will not affect the other one because they are different. This is how value type works. So what about class? If you create a class and pass its instance to another object, this time a new copy will not be created. Instead, the class memory address will be passed into the object. So at the end of the day, both objects will look at the same class memory address. If you make a change within one of them, it will affect the other object. Let me explain it in an example. Suppose you have a car, a beautiful one, and your friend also needs a car. If you allow your friend to use your car, that means both of you will use the same car. If you refuel your car and whenever one of you drives the car, the amount of fuel will reduce. This is how reference type works. If your friend buys a new car instead of using your car, then you will not be affected by him. Every one of you will use their own car, and this is how value type works. So let's create a simple class and a structure. To create a class, we're gonna use class keyword, and then let's give a name. Let's say red car. Open your curly bracket and close it. And to create a structure, we're gonna use the struct keyword, and we'll give our name. Let's say blue car. Open your curly bracket and close it. Before creating an instance from them, let's define an initializer. We can think about the initializer as a function that returns nothing. This initializer is used when we create an instance of a class or structure. In class, we have to define an initializer, while in structure we don't have to, because structure comes with a predefined initializer. We can also put parameters into an initializer while defining, or we can also define multiple initializers with different parameters. Let's create an initializer without any parameter. To do that, we will use the init keyword. As an init, open your parentheses and close it, and then let's open our curly bracket, and close it. So when we create an instance from the red car, this initializer will be executed. So let's print something inside this initializer. Let's say red car initialized. And let's do the same thing with the structure. We can copy the red cars in it, and here we can say blue car initialized. Now let's try to create an instance of these guys. Let's say var my first car is equal to red car. Open your parentheses and close it. Let's define for the blue car. Let's say var my second car is equal to blue car. All right. When we hit run, we will see the initializer will be called and the print statement will be executed. Let's hit run. And there we go. The both print was executed. This is the most basic definition and usage of class and structure. Let's define another initializer with a parameter. Let's say init, open your parentheses and close it. And inside, I want to get a message. Let's say my message, just like we did in function, and specify its data type. Let's say string, and open your curly bracket and close it. And inside, I want to print the my message. And let's copy this, paste it in the structure. So let's try to initialize red car and blue car with the second initializer. Let's say my message is hello world 1, and for the blue car you can say my message is hello world 2. Let's hit run, and the second initializer with the parameter was executed instead of the first one. Well, before adding some other properties into these guys, let me explain properties. Properties used to associate a value for a class or a structure. Definition is the same as defining a variable or a constant. There are two different properties. These are, let's delete this and let me write down properties. And these are start properties and the computed property. As the name suggests, the start properties is used for storing a constant or a variable value for a class or a structure. So when we need to store data, we use store properties. Computed property does not store value like store properties. It is used to retrieve or set store properties data. We can also add some calculation while retrieving or setting data. So let's add a store property in our class and structure. We will also see the difference between reference type and the value type better. Here, let's define again a class, let's say red car again, and for the structure, let's say blue car. And here, inside the red car class, let's define a property. Let's say var amount of fill is equal to 0 for the initial value. And let's also create our initializer. And we can say red car is initialized. Let's copy this and paste it for the struct. So we just defined a stored property called amount of fill inside the class and the structure. So first, let's try to create an instance from red car. Let's say var my red car is equal to red car, and let's try to create a new object, which is my second red car is equal to my red car. And in the next line, let's try to print the my red car amount of fill, and also let's print the my second red car amount of fill. Hit run. Here we can see at the beginning, the both object has the same value, which is 0. So before print, let's try to change the my red car amount of fill as 100. And let's hit run and see the result. Here we can see, even we just change the my red car amount of fill property, the my second red car property was also affected. It is because classes use reference type when we pass an instance to another object. This is how reference type works. Let's try to do the same example for structure. Let's delete this and create an instance from blue car. Let's say my blue car is equal to blue car, and here let's create another object. My second blue car is equal to my blue car. Let's try to print my blue car dot amount of fill, and also let's print the my second blue car dot amount of fill and hit run. It is all right. It shows the initial value, which is 0. Let's try to change the my blue car amount of fill. Let's say my blue car dot amount of fill is equal to, let's say, 200, and hit print. Here we can see the only my blue car amount of fill property was changed. Let's also try to change the my second blue car amount of fill, let's say 150, and hit print. And we can see that each object was stored its own value because structure is value type. When we create an instance and try to pass the instance to a new object, it will create a copy of that. So the both object will look at the different memory address. Well, let's add a computed property. Let me delete this. And here, after the amount of fill property, let's create var refill, and I'm gonna define its data type, which is integer. And here, open your curly bracket and close it. Remember, computed property does not store any value. Instead, we can define get and set properties. Let's say set also. Here, when we try to get the refill value, we can return the amount of fill. And also, when we try to set the refill value, we can grab the value and define it into amount of fill. Let's say new value. New value is a predefined property, so we don't have to define it, but you can also define your own parameter. I mean, we can say new amount, and instead of using new value, we can use new amount as the parameter. Let's copy this and paste it for the structure as well. Here inside this computed property, when we try to get the refill value, the get property will be triggered and the amount of fill will be returned, okay? When we try to set the refill value, we will grab the value into new amount parameter, and we are going to set the amount of fill with the new amount value. So let's try to create an instance from red car. Let's say var my first car is equal to red car, and first let's try to print the my first car amount of fill, and in the next line I'm gonna try to refill the value, let's say 100, and in the next line let's try to print the my first car amount of fill again. Let's hit run. Here, in the beginning, in the first print, the amount of fill value is 0, which is default, right? When we try to refill as 100, it will set the amount of fill with the value that we defined to refill. And when we print the amount of fill again, it printed 100, just as we expected. We can also get the amount of fill value by calling the refill. Let's hit print. And it is the same result. Let's do the same thing for the blue car structure. We can just change the name as blue car and hit run. The same result, but we forgot to change the print statements. Let's say blue car for prevent misunderstanding. This is how computed property works. So before moving on to methods, I want to talk about property observers. Property observers are called every time when the stored property value is set. There are two child property observers that are called when we set value to a stored property. These are, let's write it here, property observers. And these are will set property observer and did set. So let's delete this. And here will set property observer is called right before the store property value is set. Did set property observer is called after the value was set into property observer. So let's apply these property observers into our class and structure. We can delete this. Let's also delete the refill computed property. Here, let's make some changes on amount of fill. Let's say it is an integer type. We can also give an initial value, let's say 0, and open your curly brackets and close it. Inside, let's try to define will set property observer and also open your curly bracket and close it. Inside, let's print something. Let's say amount of fill will be, let's try to grab the new value. Remember, new value is predefined. Also, let's define did set property observer, and inside let's print amount of fill was changed from, let's try to grab the old value to what? To amount of fill. So let's copy this and paste it into struct as well. Here, let's try to create an instance from red car. Let's say var my red car is equal to red car. And let's try to change my red car amount of fill, let's say 150. When I hit run, we can see first the initializer was called, and after that, when we try to set the amount of fill value, the will set property observer will be triggered first, and then after setting the value, the did set property observer was called. If I change the red car and say blue car, let's say blue car, and do the same thing for the blue car, let's say 250 is my amount of fill, and hit run, and we got the same result in structure as well. Now it's time to talk about methods. Methods actually are functions that are associated with an instance of a class or structure. It works like functions. Let's see how to define a method inside a class and a structure. First, I'm gonna create a simple class that has two parameters. Let me delete all of this and define a new class. Let's say class person. Inside the class, let's define some parameters. Let's say var name is string and surname is also a string. Let's try to define an initializer. It will get the name and surname parameter. So open your curly brackets. Inside, let's try to set our name and surname properties. Let's see, self.name is equal to name and self.surname is equal to surname. So here we use self because our property name and the parameter name is the same, right? If you use the same names, we must mention which is property and which is parameter. If you put self keyword before the name, it will look at the properties. And if you don't add self keyword before the name, the Swift compiler will know that this is actually a parameter. So this is parameter and this is properties. Now inside this class person, let's define a method. Let's say func, just like we did in function, and let's define a name, get full name, and it will return a string value. So inside this method, let's try to return the name and with a space surname. So at the outside of class, let's create an instance. Say var my person is equal to person, and name is, let's say, Badat, surname is also as always. So let's try to print the my person gets full name and hit print. Here, the getFullName method returned a string value, which is name and surname, and print it out. So let's create a structure and add a method. Let's delete this and say struct. This time, let's say employee. Inside, let's create name. Let's also create a surname, which is string. And let's add another one. Let's say var salary is integer this time. So in struct, we don't have to define an initial value because struct comes with a predefined initializer. So we don't have to define an initializer. Let's define a function, actually a method. They get employee info, and this method will return a string value. So inside, let's say return name and also surname. And let's say your salary is, let's say salary, but salary is integer. We must cast the salary as string. And at the outside of struct, let's create an instance var my employee is equal to employee, and you can see the predefined initializer already grabbed the parameter we just defined. Let's say name Badat, surname is Oslo, and salary is, let's be generous and say 50,000. So in the next line, I'm gonna print the myEmployee.getEmployeeInfo method and hit print. As we expected, the getEmployeeInfo method was called and its return value was printed out. Alright, let's leave it here. We are gonna see some other details about class and structure in the future chapters. Keep in touch. See you in the next one. Goodbye.